Let's see. This code should work. Here we go. Oh, darn, the red MATLAB screen of death again. Let me try again. Okay, I see the error I made. Here we go. Yes, it's calculating the standard deviation. Should be done pretty soon. The standard deviation of static stability should be calculated, and then I'm well on my way. Oh, I guess I should have introduced myself. I'm Alex Kowaleski from Winter Springs, Florida, and I'm a rising senior at Davidson College, a small school in North Carolina. I'm actually a history major, but I plan to go on and study atmospheric sciences in graduate school. That's why I applied for this program. My research this summer consisted of working with Dr. Dargan Frierson of the Atmospheric Science Department. We analyzed static stability in global climate models. Static stability is a measure of stratification of the atmosphere, generally with temperature. Static stability is important because it determines how easily air can rise. When static stability is high, air cannot rise easily. When static stability is low, air can rise easily, which allows convection, and therefore, when static stability is low, it's easier for storms to form than when static stability is high. Specifically, Dr. Frierson and I looked at static stability in the mid-latitudes, the area between 30 and 60 north and 30 and 60 south. My research this summer uncovered some interesting information about how static stability varies by season over the northern and southern mid-latitudes. When you look at dry static stability, or static stability when moisture in the atmosphere isn't taken into account, we see that there's much greater seasonal variation over the southern hemisphere than over the northern hemisphere. This is because the southern hemisphere mid-latitudes are almost entirely ocean, while the northern mid-latitudes are a mixture of land and ocean. Because over ocean static stability is much higher during the summer, while over land static stability is much higher over the winter, the northern hemisphere, which has a mixture of land and ocean, sees no great total seasonal variation by latitude, while the southern hemisphere does. However, when we look at the northern hemisphere regions individually, we see that water over the northern hemisphere, like water over the southern hemisphere, has much greater stability during the summer. When you look at moist static stability, we see that the variations are much greater in the northern hemisphere than the southern hemisphere. This is because moist static stability varies seasonally much more over land than over ocean, and the northern hemisphere mid-latitudes have much more land than the southern hemisphere mid-latitudes. I really got a lot out of my research experience this summer. I'd like to thank JISAO and my mentor, Dr. Frierson, for accepting me into this program. I really had a blast too in beautiful Seattle, and I learned a lot, both about how MATLAB works and how the research process in general at a large university such as the University of Washington works. Not to mention that I learned a lot about dry and moist static stability. I'd really recommend JISAO for any undergraduate student interested in graduate school in the atmospheric or oceanic sciences.